I have a few questions for you before we start. The first question is, how many of you here don't speak Greek language? Just 1, 2, 3, 4, and me, 5, 6. There are 6 people. So this is international conference, which is good. Another question is, how many of you actually are developers, programmers? So how many of you write code? Perfect. And how many of you write Java code? Okay, it's about 30%. That's good, because I will have examples in Java, but they're not so complex, and I think most of you will understand them. They are cross-language, so they will not be complex. And the talk is not going to be very technical, even though I'll show some Java code, but the talk is going to be more conceptual, and I will try to convince you that in order to make our software more stable and more robust, we need to make it more fragile. That's kind of controversial idea, but I'll try to deliver you this idea, and probably you will be convinced. Let's just jump straight. A few words about myself. I'm a Java developer myself. I'm an architect in a few projects, and I'm a CTO of my own company. So I do write code, I architect our projects, and I manage. Jesus, it's too loud. And I manage programmers as well. So I know about like 3 levels of the situation. I know how to write code, I know how to control the quality of the project, and I know how to manage people and to get money from customers and to make sure that we're actually paid for the software we're delivering, so the software is actually stable. So the first question is, I just have a few slides, so don't worry, it's not going to be too long. The first question is, what actually robustness means? So what do we need to do in order to make our software more stable so that our customers are more happy? It actually means less bugs. So the less bugs we have, the more stable is the software, the better it is for our users and for our customers, for everybody. And at the same time, this is obvious, but at the same time, it's not really usually obvious to everybody that any software has almost unlimited amount of bugs. So it's only a question of how many of these bugs we can actually discover there and how many bugs that stay there undiscovered. So that's the balance we need to keep. So we need to try to discover as many problems as possible, to find them, to fix them, and that's how we make our software better. That's the fundamental idea. So we shouldn't, which we need to understand, we shouldn't hide bugs. We shouldn't get away from them. We shouldn't try to say that there are no bugs and this is perfect. We need to admit that our software is full of bugs, and the question is how many of them we already managed to find and fix. And how many are still there, we don't know, but probably so many that there are so many of them, and probably it's unlimited amount of them. So that's the idea, which is important to understand for the further discussion. And I want to show you, basically, to compare 2 approaches. One is called fail fast, another one is called fail safe. So how many of you have heard about fail fast? That's cool, about 10%. And how many of you heard about fail safe? The same 10%. Perfect. So for others, which is good, so I have some new for you, some new information. So there are 2 approaches. The first one is called fail fast, another one fail safe. Fail safe means that when something goes wrong, our software has to try to save the situation, to do whatever it takes to rescue this problem and continue working. So if something goes wrong, for example, let's say the disk is full, we don't have any more space to save the file, then the fail-safe approach will try to do something and, for example, keep the data in memory, but still continue to work. That's the general conceptual fail-safe approach. So as a software, I never fail. I try never to fail. I try never to show to my customers, to my users, that something went wrong. I'm trying to do all I can in order to save the situation and continue the execution. This is fail-safe. And fail-fast means that if something goes wrong, I immediately try to break myself. I try to fail. I do all I can in order to stop the execution and to not to continue. So I'm trying to show to my user that there is a problem. To the user, to the client, to another software module, to whoever is talking to me. Every time I'm having a problem, I'm breaking. That's 2 approaches. And even though the first one, fail-safe, looks better and more intuitive to design the software so that it actually tries to save itself and not to break, the fail-fast is way better. So that's the point. That's what I'm That's what I'm telling you today. So fail safe is bad, fail fast is good. So every time we're trying to make the software so that it saves itself and trying to find a way not to fail, this is bad for us. That's strategically bad. So in the end, we will have the software which breaks more often, which is not that stable, which is not robust, which is full of problems. But if we make it the way with the fail fast recommends, if we try to always blame our clients instead of blaming ourselves, always saying that something is wrong, I'm not going to continue. I don't have enough disk space, so I'm not going to continue. I don't have enough memory, I'm not going to continue. I'm going to fail right there and here. This is the error message. Then in that case, the software will become more stable. Does it sound controversial and unusual for you? For who of you it does sound unlogical, illogical? That's good. That's good. So we need these people, and then I'll try to prove you and demonstrate why I think so and why it works for our projects first of all, and it should work for your projects as well. This is the last slide before we go to the Java code. So that's how I think, in general, the life cycle of any software should look and looks. So there are basically 4 steps. First of all, we fix something. Let's start from the fix. So we fix or implement something. Fixing, implementing is kind of the same. So we have some piece of software, for example, already something, and we have some features, new features to add, or we need some bugs to fix. So first of all, we fix them. The next step, we deploy them. Deployment means, you probably know what it is, you just package this stuff and put it to production. Maybe you upload it to Apple Store, or you put it to the web server, or you package it all and deliver the executable file to your desktop users. It doesn't matter, but you deliver the software to the user. Then the step number 3, these users or testers, they start to use your product. They start to use and they eventually hit the bug. So they face the problem, and eventually there will be some problem, and they face this problem. And then we need to report this problem somehow back to programmers. And then programmers fix that problem. Again, deploy the new product, the new version. Again, the users try to use it. Again, they see the bug, and it goes again and again and again. So the software will become more stable, and we will be able to discover more problems faster if this cycle is running fast and is running frequently. So if we, as managers or architects or people who control the project, if we can organize the project so that this cycle works fast, and we can fix the problem, deploy it in 5 minutes, put it for the user in 10 minutes, and then get the report from the user in another 10 minutes, and then fix it in another 10 minutes. So in 30 minutes, we run the full cycle. Then the bug will be removed in 30 minutes, and we'll be able to jump to the next version, and then jump to the next version. So the faster we spin this cycle, the better for everything. The faster we will be able to discover our problems and then fix them, and the software will become more and more stable. So and then the core point, if we fail fast, if the software says, I can't work anymore on that step, on the step which is called use, then the reporting will be faster and the fix will be faster, and we will be able to eliminate and remove our bugs faster. We'll get back to it after I'll show you 6 Java pieces of code. You ready for them? Again, don't pay attention, this is Java. This is the same and almost the same code in PHP, almost the same code in Ruby. In JavaScript, almost the same. So the first example, so what exactly it means fail safe comparing to fail fast. On the left side you see fail safe. Do you see the code? Who doesn't? Who doesn't see the code? Everybody. Okay, good. So on the left we see the bad code, on the right we see the good code. So on the left side, let's say it's a function which accepts a file and it is supposed to return the length of the file. So we're supposed to calculate how many bytes are in this file. And we check, what if you give me the null as a parameter? What if as a function, I'm receiving null as a parameter? What do I do? This is obviously a situation where somebody is trying to give me something which is not what I'm expecting. This is not a file. I don't know what to do with it. I cannot measure how big is the file. So this is the left example. I'm still trying not to break. I'm still trying to help that guy who just called me. So I'm trying to be nice and polite. I'm trying to return something, not to break the execution, because I want to survive. I want this software to continue executing. So I'm returning -1. And this is really bad. This is wrong approach. In this case, this -1 will go up to the client, and the client will not, probably the client will check this, will check it later and say, if -1 is returning, then probably the length of the file was not able to be calculated. All this dancing around. But that will create even bigger problems for the client, because maybe the client will not check that. And in that case, this -1 will create a bigger problem for the future, will create a bigger problem for the client who is calling this function. So the right approach is on the right. If we are getting some argument which is not what is expected, then we immediately break the execution and say, this is an exception. I don't want to continue. You made a mistake, you as a client who is calling me. And I'm not gonna help you to solve this problem. This is your problem. So I'm trying to be as negative towards your mistakes as possible on the right side. So I'm always throwing an exception when the parameter is not good for me. The left side is called fail-safe, the right one is fail-fast. And I'm sure that many of you actually use that approach right now. And I'm suggesting to use that one. So every time anyone is giving you parameters which you don't like, immediately break the execution and throw an exception. Because in this case, this exception will go up and up and up, remember that cycle, and eventually will be visible to the user or to somebody on the higher level. And then it's going to be a bug, and that bug will be properly fixed. But if we return -1, it may never be a bug. We will hide this problem. So we have some client who already has a bug because this client gives me null instead of the file. So that is the bug. But by returning -1, we're not revealing this bug. We're not making it visible to everybody. Instead, we're just hiding it and trying to survive. And that's bad. We need to make our bugs visible, not hide them. Clear example? I can continue? Good. Example number 2, I have 6 of them. Example number 2, again is Java, but still exceptions, you should probably understand it. On the left side, we have a stream, and I'm trying to read 1 byte from the stream. The stream is the source of input-output stream in Java. So I'm trying to read, and that read operation is throwing exceptions. So if something is wrong, for example, the file is gone or there is no connection to the socket or something, it doesn't matter where the bytes are coming from, they may throw input-output exception. So that's an exception which may flow out of there. And on the left example, on the left code sample, I'm catching that exception, and I'm just printing the exception on the console, and I'm continuing. This is called, also known as exception swallowing. So I got an exception, but instead of making this exception turning this exception into a bigger problem, instead I'm trying to swallow this situation, to hide that situation, and continue the execution. So I'm trying to be safe, while I have to be fail fast. In that example, every time I catch an exception, I throw another exception, saying something like fail, I cannot read from the stream, there's a bug here, I can't continue. So on the left side, if we code like that, then the execution will continue after the exception. And who knows what's going to happen later? We are making the situation unpredictable on the left example. We don't know what's going to happen later. We just got a problem, maybe, I don't know, maybe there was a connection to the web page or to the socket, to the network socket or something, and we were just getting bytes by bytes, and then suddenly the connection got lost. We just got the internet is off. We don't have any more internet connection. Well, we don't show that to the user. We're trying to continue the execution while the situation is completely now unpredictable because there's no connection. So we need to throw an exception. We shouldn't take the blame for this situation on our shoulders. This is not our fault. This is not my fault in this code that the connection is lost. This is not my fault that the stream cannot give me the byte. So I need to throw an exception. I need to make the problem visible. Again, I'm sure you've seen a lot of such examples of this code, even in books, in Java books, in PHP books, and in many books about programming. They keep using that. So they catch an exception, they print the stack trace to the console, and they continue. Even the IDEs, even this IntelliJ, for example, or NetBeans or Eclipse or whatever, when we have an exception, there is a shortcut. You can click the button and say, like, catch an exception. They will put that code in there. This is like a typical mistake, typical anti-pattern, which we shouldn't use, this exception swallowing. So every time, that's what I'm suggesting, every time you get an exception, make it a bigger exception. This is also called exception chaining. So I'm getting one exception, I wrap it into a bigger one, You see the X is used there as a parameter to the constructor. So I get one exception, I wrap it into a bigger exception and throw it out. It's called exception chaining. So they eventually may have more and more and more and more exceptions. And when the exception floats up to the higher level, it's a big, huge exception with many, many, many other exceptions included inside. And when that exception is reported to the end user, then it's possible to the programmer, to the end user, it's possible to go down in the stack trace and see exactly what caused that exception. So we make this visible to everybody, to users and testers. Is it clear? Can I continue? Perfect. Example number 3, a bit more complex. So let's say we have a function push, which is supposed to put the number into array. So, and the array has the length. So first of all, I'm checking if the current position of the array is still within the boundaries of the array. Then I'm going to push the number into current position and increment the position number. Quite easy. Right? So we have an array, and then the position shows where is the last number in the array, and the client says, put the new number into the array. So what I'm doing is I'm checking if the position is less than the array length, then I put it there. What happens if the position is already outside of the boundaries? Nothing. It will be just ignored. So nothing will happen. When the push method is called, then if the position is already outside of the array, absolutely nothing will happen. And the client who is calling me and asking me to put some integer number into the array which is already full will not know about that situation. This problem, which is a problem, will be completely invisible to the client. So the client will not understand what happened. The push method is called, but nothing happened. It looked like everything was fine. So the client will be able to continue the execution because the push method basically ignored the problem. So this is fail-safe. We didn't break, the software keeps running, the client is happy, nothing is down, but this is wrong. And this is fail-fast. First of all, we check if we are already outside of the boundary. And then we throw an exception and say array is already full. I can't continue. And then we add it to the array and increment the position. So this is very typical fail-safe approach where people thinking that it's better to be safe, it's better to be polite to our clients and not break as much as possible. Instead, we need to try to hide these problematic situations and let the client probably later solve it somehow. This is wrong. This is right. We keep blaming. We're basically blaming the client here. So we're telling the client, you know that the array is full, or maybe you didn't know about that, I don't care. I'm just immediately telling you the array is full, solve that problem on your side somehow. But don't call me, don't call my method push, because I'm full. I can't put anything else into the array. Again, fail safe, fail fast. In that case, we will have a lot of exceptions. The software will break often if you design it that way, because all the pieces of software, they will blame each other. And each module, each class, each method will be accepting only the situations which are perfect for them. If something is imperfect, they will throw exceptions. So initially when we start designing the software, we will have many exceptions everywhere. It will be really fragile, so-called. So it will fail and break in every second button you click. You will be clicking, you will be trying to use it, it will break and break and break. It will throw exceptions in so many cases, and which is good. Because in that case, you will have the sources, you will have the material for you to work on. You will fix them and deploy again. You will fix them and deploy again and put it on use again. So initially, when you start designing the software, we need bugs. We need bugs to be visible for us. We need them to be jumping into our face. And then we'll be able to fix them and deploy again, fix them and deploy again. So we will run that cycle intensively and frequently and many, many times a day, which is good. If we do it that way, we're going to have less bugs when we start to develop the software. But in a few months or in a few years, we will have more of them and they will be completely unclear for us because they will be coming out from really strange places where we would not be able to understand what's going on. Like in this case, I call the push, I expect this number to be in the array, nothing happens, I keep running, and then suddenly at some point of time, I'm getting some numbers from the array, but my number X is not there. So that's going to be a big puzzle for me. Like, how come I just pushed that number and then I'm trying to get it out of there, but it's not there. And then I will need to go in, I will investigate, and then probably I will find that, that's the problem. The array actually did, the list actually did not accept my number. They basically ignored the situation of the array is full. And that will take way more time. So that's the point. We need to make problems visible. Is it clear? Can I continue? Good. Example number 4. This is again Java, but in other languages which have interfaces, or it's not only about interfaces. Let's say we have a method save, and the method save is not implemented yet. So I just created a class, I put some methods in there, and there's method save which is supposed to be there, but I don't know how to implement it so far. So I'll do it later, maybe tomorrow. I don't have time today. So what I do, I say not implemented yet. This is just a comment there. It's not a real code. So when somebody will call method save, what is going to happen? Nothing. Nothing will happen, nothing will be saved, nothing will be executed. The client will not understand that they actually called the method which was not implemented. So they called something which is not there yet. Is it a mistake? Definitely. Will the client understand that this is a mistake? No. The client will continue. The client will assume that everything is fine. I just called save method and the save actually saved something. That's the wrong approach, but it's safe because the client will continue to work. In that case, we throw an exception and we say it's not implemented yet. And in that case, the client will be at fault. It's going to be the client's fault, not my fault. The client will call method save and the execution will immediately break. They will not be able to continue. So this is the right way, and I've seen a lot of examples how people use that way. So they create the skeleton of the class, they make the methods, and they put comments, saying this is not implemented, I'll do it later, this doesn't work right now, but they are comments, not exceptions. I'm saying that they have to be exceptions. So every time something is not implemented, we need to throw exceptions and show to our clients that we cannot continue. I'm just giving you this example just to illustrate the idea of fail fast. There could be more examples. I just selected a few of them from my Java experience and demonstrating you. Because the main idea is that's what I'm trying to tell, is that we need to fail as soon as possible and as many times as possible. And that's a demonstration. Again, I think it's clear, right? Yes. We have 2 more examples. This is almost the last one. This is Java. In Java, when you call file.delete, they delete the file and then they return true or false. True if the file was actually deleted, and false if the file was not deleted for some reason. I don't know why they designed it that way, Java, but this is the way it's designed. And we just call file.delete. This is a mistake because we ignore that answer. They are telling us something. They're saying, I was not able to delete the file. And that is an information for us that this is a good chance for us to fail. This is a perfect opportunity for us to fail. So if we design the software in a fail-fast approach, we need to always look for an opportunity to fail. So where else I can break my code? Where else I can throw an exception? That's going to be the mentality if you think fail-fast, in the fail-fast mentality. You should think about how many more times I have an opportunity to fail. In how many more places I can throw an exception when something is not really perfect for me. And this is the good opportunity. You call the file, if the file delete returns false, if it's not, then the file was not deleted for some reason, then I throw an exception immediately. Because as a programmer, I'm looking for the next opportunity for me to where else I can throw an exception. That's fail fast. Because in that case, on the left side, it's fail safe. Yes, we tried to delete the file, it was not deleted, okay, who cares, let's continue. But that's a good chance to say that something went wrong for some reason. Maybe it's not the right file. Maybe the file name is wrong. Maybe we just made a mistake earlier and the file which is supposed to be there, I cannot delete it because it's gone. So maybe somebody else deleted it. Maybe it was not created in the first place. So many options. And for me, it's a good chance to tell the user who is using it that this is a good chance for you to report it as a bug. And then somebody will fix it and we're going to deploy it and the software will become better. So every bug is a chance to make the software better. So every time we find the bug in the software and report it and fix it, the software becomes better because there is -1 bug in it. Less than 1 bug. We had 1 million bugs in there, now there is -1. Then there's -2, then there's -3. So we keep removing bugs. And reporting and exceptions is the perfect instrument to tell us where the bugs are. So it's like self-healing instrument for the software. Make sense? I hope it does. The last one, the last slide, and we're close to to the finish, to the questions. Let's say we have a function, a method find, which is supposed to find a user in the database, for example, by the number. So I give the number, and it goes to the database, it finds the user, and if the user is not found, it returns null. This is the very typical anti-pattern, returning null when something is not found. It's very popular in Java and PHP, in different languages. If something, in Ruby as well. If something is not found, return null. If something is not clear, I cannot return you the object you're expecting, I'm returning null. And this is really bad. Again, it's a fail-safe approach. Because in this case, we're trying to be polite and give you at least something. You ask me for the user, I'm going to give you at least something. And then it's up to you what to do with it. Try to check whether it's null, and then you make a decision. On the right side is a fail-fast approach. I can't find the user, I throw an exception. I'm not going to return you null. Again, I think it's obvious why the left one is bad. Because null means that nulls goes up and up there to the client. And we don't know where exactly it's going to turn into a bug. So this null, that the client later may try to call some function on this null, and it's going to be null pointer exception. So it's going to be an exception later. And it's going to be very difficult, maybe not so difficult, but difficult, more difficult to find why exactly we have null instead of a user. It's good if we get the user and immediately call something on this user. Then we will see, okay, this is the method which returned null, and this is the next call which is trying to read this something from the user, the name of the user, for example. And then we have null pointer exception. That will be more or less okay because they stay next to each other. But what if I get the user and I save it somewhere, and then in a few minutes or maybe in a few hours, I'm trying to use that stuff, to use that user, and there's null over there. How will I know who actually created that user? The link between these two pieces of code will be not so obvious. So this is the problem hiding approach. In general, null in object-oriented programming is kind of, it's an anti-pattern, mostly because of that, because it's not a real object, it's something which substitutes the real object, and then it's difficult later to understand why do we have null instead of the real object. So in this case, we blame the user. We're saying, hey, you just gave us the number, which I don't understand, I don't have that user in my database, so here's an exception for you. Now it's your problem. Deal with this problem. You found this, you gave me the number. I don't know where you got this number, but this is your fault, and just do something about it. That's probably what I found in my code. There's just 6 examples of Java code where I think fail-safe compares to fail-fast. They're quite practical. So if you look at your code, I'm sure you will be able to find similar cases, but the idea always is the same. Every time you have an opportunity to fail, fail. And here's my last slide. Probably I made a mistake with the numbers. So, so this is the last slide. Yeah, I have actually. Huh? Yeah, there should be an exception, definitely. So that's a mistake. You see? Yeah. So if we see that, then I will fix it, and then the presentation would become better. But it's too late, right? So here's the cycle again. Again, back to that slide. So we have fix, deploy, use, and report. And there isn't one new arrow I put there. So traditionally, when we design the software in a traditional way with the fail-safe approach, then we have this link, which is called sometimes log files, or sometimes some monitoring software, something like that. So we do not remove this, we basically kind of remove this functionality from the end users. So what happens? We fix something, we deploy it to production, people start using it, we're looking at the log file. So what's going on in the production? We are trying to hide that information from real users, and we are looking at the logs and trying to report ourselves. So we kind of take away the function, the feature, the ability to report the bug back to us from the real user. But the user has to have that ability. The user should be able to report the problem back to us. We need to be able to implement that functionality into the software. So the software has to be able to show to the user, like, boom, something happened, this is the full detailed report, just click that button and it's going to go back to us, to the reporting software somehow, and we will jump into fixing it right now. So we need to use our customers, our users, our testers, our project sponsors, everybody, as a valuable element in this cycle. Make them work for us, make them report bugs back to us. And in that case, we will be able to fix them faster and make the software more stable. So that's my final point. So make sure that your customers can report information back to us. They can report bugs and make that bugs visible. In this case, when you start developing the software, it will be full of bugs. It will be really fragile. It will fail here and there. But very soon, you will get so many bugs back. You will fix them. You will deploy new versions. And the software will start to become more stable. And then it will be more and more and more. And in some time, it will be so stable and you will be so confident that every time something breaks, your users will immediately report it back to you. And you will be able to redeploy, fix, and put back the new version. So that's the concept. I'm done. This is information about myself. This is my blog. You can follow it. You can read it. Do you have questions? Thank you.
Thank you very much.
You can just say, I'll repeat the question anyway.
We have 5 minutes.
5 minutes for the questions, yeah.
Run, rolla, run.
I think I'm taking time of the coffee break, right? Sorry about that.
Hi.
Yeah.
Thank you very much first for the talk. And I have a question. You said that IDEs, even Eclipse, uses this fail-safe approach at many places where it automatically substitutes code. Have you seen any tools to help you search for this type of code, which are kind of fail-safe code?
Well, it's a good question. I'll repeat the question probably. The question is if I just mentioned that most IDEs, unfortunately, they use fail-safe approach. So they are trying, probably because this is just traditional approach in the industry for many years. So they are trying to help us to be fail-safe, which is wrong. And the question is, do we have some tools which will help us to be fail-fast? I'm using some static analyzers in Java, for example. And some situations, they will help you to resolve. For example, this one, when we do not check what's the return, what's the result of the delete method, then the static analyzer, static analysis some of them will tell you that this is wrong. You should check the output. That's probably one situation. But in general, I don't think these tools exist. I don't know them. I don't know such tools. So it's more about thinking than just automatically checking. So the answer is no, I don't know them. But maybe that would be good to create something like that. But that's kind of complex because both ways are legal in Java, for example. You can do left, you can do right. Both examples will compile. They will compile and they will work. So it's not about bad written code. The code is perfect. I mean, the code is written correctly on the left side and on the right side. It compiles, it's properly formatted, it's clear, we know what it does. But conceptually speaking, and on a large scale, this one on the left will lead you to the software which will be less stable.
Next question.
Next question. Yeah. You can just, we need a mic, huh?
Hi. Don't you think fail fast method imposes a security risk? It might, for instance, expose the database schema, or it might even expose the information of a user to, like imagine the case of a web application. So doesn't it impose a security risk?
Yeah, it does, definitely. The question is, I'll repeat the question, so do we have a risk of exposing some sensitive information, for example, database password or something, or maybe the structure of the database, to the user when we show the stack trace, for example, when something goes wrong? Definitely that's the case. So we just need to make sure first of all, we need to make sure that our exceptions, when we throw them, they don't contain the sensitive information. But sometimes we may make a mistake, right? We may make a mistake and still put some valuable, some sensitive information into the text of the exception and say, hey, I tried to connect to the database using this login and this password, but the database is gone. And then this is the text of the exception. And this exception goes up, and then the user opens the website, and then boom, some application is not available, but instead of seeing this page 503, like we are sorry, internal application error, the user sees the full stack trace with the information of how exactly we tried to connect to the database, using which password and which login, and how we failed. That's a problem, but I think that even if you do it like that, even if the user sees this information, I think it's less, I mean, security-wise, that kind of information, in my opinion, is not going to really damage the whole security situation, the application. Because in most cases we have firewalls, in most cases this information about passwords and usernames is not going to help the real hacker to get in. But this is, I'm not a security expert. But in general, just, I believe that the more open the application is, the more you open your application, the more you make it available to white hat hackers, to people who are like, they have good intentions, the faster they will find that problems and they report it back to you. So as soon as you have this mistake and you expose this sensitive information, somebody will get back to you and say, hey guys, you just exposed something, how about you fix that? That's my experience over the last 5 years of making web apps and doing it that way. So we expose all our apps, and some of them are even open source entirely. So we just make a web app and we put the entire code on GitHub and make it completely open source. And then I see it by my experience. When I do it in the first few days, it definitely has security problems and it definitely has some bugs like that. And somebody emails me back and say, hey dude, you made a mistake, you fix it there. I just telling you how somebody can break your system. And I fix it and I continue and it becomes more stable. Maybe I'm in this approach, this is a conceptual question, but compare Microsoft approach and Linux approach. Linux is completely open and it's way more stable. Microsoft is completely closed and it's full of holes and full of troubles. So the same here. So make your application as open as possible, and good people with good intentions will report the problems you have way faster than real hackers who wants to get in. That's my belief. Maybe I'm wrong here, but I'm saying what I think. So I'm making all my applications as open as possible.
One last, maybe two last if you are...
Two last.
I have no problems with your slides up to this one.
Up to this one?
Yes.
Okay.
All the previous slides are very good programming practices. My question is about this one because this is not necessarily a bug. The fact that you are looking for something in the database, for example, might not be a bug. You were looking at the user web application. By the time you decided to get more information about the user, someone deleted the entry. It's not necessarily a bug. So are you suggesting to use exceptions even for not exceptional circumstances? Because this, to me, is not an exceptional circumstance. It's not a
good
bug.
question. Yeah, good question. I'll repeat it. So in this case, this is definitely maybe not the exceptional situation because the application may be looking for the user in the database, and this may be a legal situation. For example, we're checking whether the user is in the database, and if the user is not there, then we do not do something, and then so this could be a perfectly legal situation. The user is in the database, or the user is not in the database. But in this case, I'm saying that exceptions should be used only for the situations where the application is intended to crash. So exception means that something really goes wrong. So in this case, I'm saying that the find function is supposed to be used to find the user which is definitely in the database. And in that case, I crash. So if this is not the full design, so probably I need to have one more function which will say exists, for example. The one which will allow you to check whether the user exists. And in this case, probably the message will be user not found, comma, please use exist function. So this means that you are abusing my protocol. So I have a protocol where the find function is expecting definitely the number of a definitely existing user in the database. And you're using it in a different way. There's a term called flow control by exceptions, which is an anti-pattern. So who knows what it is? Okay, perfect. So I'll explain. So exceptions are not made to control your flow. So if in this case, for example, look at this example. So if in this case, I'm the user of this function, and I'm doing exactly that. I want to check whether the user is in the database or not. So I'm calling find 555. And I'm expecting exception or the real user. If the exception is thrown, I catch the exception, and I'm saying to myself, okay, now the user doesn't exist there. Let's do something about it. This is called flow control by exceptions, and this is wrong. So exceptions are not designed to let you control the flow, to decide to go left or to go right. If there is no exception, we go left. If there's exception, we go right. So we swallow the exception, we ignore this exception text because we understand, okay, user is not found, and we go to the right way. This forking is not what exceptions is for. Exceptions are for exceptional situations where the application has to completely crash. So in this case, if you want to find the user, then I will introduce you another method which will be called does user exist, for example. And then there are going to be two methods. The first one is find, which crashes if you give me the wrong number. And the second one is does user exist, which will give me the the real user, which will give you the true or false if user exists or not. So answering your questions, I think you're right. That's a right question. So we need to use exceptions only for illegal, completely illegal, invalid situations which are definitely not supposed to be there. Not for control, not for controlling which way to go, not to checking, do we have an exception? Okay, good, then the user is not in the database. That's wrong. And it's not only wrong philosophically, but technically as well, because exceptions are quite expensive. Every time we throw an exception, it's quite expensive process, because the Java or PHP or any other language, they collect the full stack trace. So they need to get the information from the stack, build an object, put all this information in there. So they need to prepare some really complex object, which is called exception. And using it for just forking and deciding whether the user is in the database or not, it's expensive. I mean, it costs time. So we have one more question and then we're done. That's the question.
Just to say, my question was answered. I mean, I had the same remark, and looking at the high performance website, and then we noticed that the performance drops down when we throw exceptions just for this.
Exactly.
So you answered it perfectly. Thanks.
Yeah. So it's like I said, maybe we have one more here. One more. Yeah, that's a good guide. So let's.
One more. Minus one coffee.
So you just said that it's not a good design to use exceptions for flow.
Yeah.
But you actually said that it is very expensive to use an exception for this case.
Yeah.
Is it more expensive than using a second query to check for the existence of the user in the database?
Yeah, that's a good question. That's true. So let's get back to this example. So let's, for example, in here, we need to basically first check whether the user is there and then find the user. So this is right. In this case, we're going to have two queries to the database. The first one will go to the database, check whether the user is there, and then the second one will actually find the user. This is not a good design. In order to eliminate this problem and make it faster, then we introduce another method. For example, this find method will return me a collection of users, which is going to be empty in one case and it will contain a user in another case, for example. So in this case, we don't return null, but we return a collection which contains a user inside. It's not really perfect design, but still it's better than using two methods. So we check the user in the database. If it's not found, we return you an empty collection. It's not null because you need to get in there and get the user. So you will see the problem immediately. As soon as you get back the collection from me, you will go there to get the first element, but there is no first element. So you will crash more or less immediately. The problem will not be populated to other pieces of the software because it will be right there. You will crash right there. So that's an option, for example. Or you can return another option, which is a better option. Instead of null, use so-called null objects. Probably you've heard about that pattern. So we actually return the user, which actually is not a user, but the user which doesn't exist. So it's a null object pattern. You can Google for it. We don't have enough time. But thanks for coming. Thanks for questions. I'll be outside.